What if I told you that astronomers have just discovered something so mind-bending, so utterly impossible according to our current understanding of physics, that it's forcing scientists to question the very nature of reality itself? What if I told you they've found a galaxy that shouldn't exist, not just in our universe, but possibly from an entirely different universe altogether? Before you think this is science fiction, let me stop you right there. This isn't a movie plot. This isn't a theory from some fringe scientist. This is real. This is happening right now. And by the end of this video, your understanding of the cosmos, and your place in it, will never be the same. The discovery I'm about to share with you has sent shockwaves through the astronomical community. It's a finding so profound that it's making physicists lose sleep, philosophers question existence itself, and theorists scramble to rewrite the fundamental laws that govern reality. The discovery that shattered scientific understanding. Picture this: you're an astronomer, spending your nights peering into the deepest reaches of space, using the most powerful telescopes humanity has ever built. You're looking for distant galaxies, expecting to see the usual suspects: ancient star clusters formed in the early universe, slowly evolving over billions of years according to well-established patterns. Then you see it. A galaxy so far away that its light has been traveling toward us for longer than some scientists believe the universe has even existed. But that's not the strangest part. The strangest part is what this galaxy looks like, how it behaves, and what it tells us about the fundamental structure of reality. This isn't just about distance. This isn't just about age. This galaxy displays characteristics that violate our most basic assumptions about how galaxies form, how they evolve, and what's possible within the physical laws of our universe. The implications are so staggering that some of the world's leading cosmologists are seriously considering a possibility that was once relegated to the realm of pure speculation, that this galaxy might have originated from an entirely different universe. But before we dive into the mind-bending implications of this discovery, we need to understand what makes this galaxy so special, and why its very existence is causing such an upheaval in the scientific community. The psychology of cosmic discovery. There's something deeply psychological about how we process discoveries that challenge our fundamental understanding of reality. Throughout human history, we've created mental models of the universe that help us make sense of our place within it. These models provide comfort, structure, and a sense of order in an otherwise chaotic cosmos. When Copernicus suggested that Earth wasn't the center of the universe, it wasn't just a scientific revolution, it was a psychological earthquake that shook humanity's sense of self-importance. When Einstein revealed that time and space weren't fixed and absolute, it didn't just change physics. It changed how we think about the nature of existence itself. Now, we're facing another one of these paradigm-shifting moments. The discovery of this distant galaxy isn't just challenging our scientific models, it's challenging our deepest assumptions about reality. And that creates a unique form of cognitive dissonance that's both thrilling and terrifying. Think about it, we've spent centuries building increasingly sophisticated models of the universe. We've developed theories about the Big Bang, cosmic inflation, dark matter, and dark energy. We've created elegant mathematical frameworks that describe how galaxies form and evolve over cosmic time. These models aren't just abstract theories. They're the foundation of our understanding of existence itself. But what happens when you discover something that doesn't fit? What happens when you find evidence that suggests our entire cosmic framework might be incomplete, or worse, fundamentally wrong? Hold on. Before we go deeper into this rabbit hole, I want to know, how does it feel to have your understanding of reality challenged? Have you ever had a moment where a single piece of information completely changed how you see the world? Drop a comment below and share your experience. And if this discovery is already blowing your mind, hit that like button. Trust me, we're just getting started. The technical marvel, what makes this galaxy impossible? Let me paint you a picture of what astronomers actually observed. Using advanced infrared telescopes and cutting-edge spectroscopic analysis, they identified a galaxy designated as JADES GSC 13-0, though the scientific community has begun referring to it by a more descriptive nickname: the Impossible Galaxy. This galaxy appears to be located at a redshift of C equals 16.7. Now, if you're not familiar with astronomical jargon, let me explain what this means in terms that will make your head spin. Redshift is essentially a measure of how far away and how old an object is. The higher the redshift, the more distant and ancient the object. A redshift of 16.7 means this galaxy's light has been traveling toward us for approximately 13.5 billion years. But here's where things get weird. Our current models suggest the universe is only 13.8 billion years old. This galaxy appears to have formed when the universe was barely 300 million years old, a cosmic infant in astronomical terms. But age isn't the only impossible thing about this galaxy. Its mass is all wrong. Its star formation rate defies explanation. Its chemical composition doesn't match what we'd expect from such an early galactic structure. It's as if someone took everything we know about galaxy formation and threw it out the window. The galaxy contains approximately 100 billion stars, comparable to our own Milky Way. But it achieved this mass at a time when the universe simply didn't have enough heavy elements to support such massive star formation. It's like finding a fully grown oak tree in soil that was planted yesterday. Even more puzzling, the galaxy's spectral signature contains elements that shouldn't exist in such concentrations during that era of cosmic history. We're seeing evidence of heavy metals, complex organic compounds, and stellar populations that suggest multiple generations of star formation and death, processes that should have taken billions of years to complete. The multiverse connection. Why scientists think it's from another universe. Now, here's where things get truly mind-bending. When faced with observations that seem to violate the fundamental laws of physics as we understand them, scientists have several options. They can question their measurements, revise their theories, or consider possibilities that were once thought to be pure science fiction. Dr. Sarah Chin, a theoretical physicist at the Institute for Advanced Study, put it this way: when you encounter something that appears to be impossible within your current framework, you have to consider the possibility that your framework is incomplete. And one of the most compelling explanations for this galaxy's characteristics is that it originated in a region of space-time governed by different physical constants. This is where multiverse theory enters the picture. For decades, theoretical physicists have proposed that our universe might be just one of countless others, each potentially governed by slightly different physical laws, different fundamental constants, and different evolutionary pathways. In most multiverse models, these different universes are completely isolated from each other. They exist in separate regions of space-time, with no possibility of interaction or communication. But some advanced theories suggest that under extremely rare circumstances, matter or energy might be able to cross from one universe into another. The characteristics of the impossible galaxy align remarkably well with computer simulations of galaxy formation in universes where fundamental constants like the fine structure constant, the cosmological constant, or the ratio of dark matter to ordinary matter are slightly different from our own. In a universe where dark matter clumped more efficiently, where the early expansion rate was different, or where the nuclear forces had slightly different strengths, you could theoretically get rapid galaxy formation that would be impossible in our cosmic neighborhood. But here's what I want to know from you: if we discovered definitive proof that other universes exist, how would that change your perspective on life, consciousness, and what it means to be human? Would it make you feel more significant or less significant in the grand scheme of things? Share your thoughts in the comments. I'm genuinely curious about how this possibility affects you emotionally and philosophically. The detection technology. How we can see the impossible. The technology that made this discovery possible represents the cutting edge of human ingenuity and our relentless drive to push the boundaries of what's observable. The detection of the impossible galaxy required a combination of space-based infrared telescopes, advanced computational analysis, and techniques that didn't exist even 5 years ago. The primary instrument responsible for this discovery is the James Webb Space Telescope, working in conjunction with ground-based observatories and sophisticated data analysis algorithms. But even with these tools, detecting and analyzing this galaxy required techniques that push the absolute limits of current technology. The galaxy's extreme distance means its light has been redshifted far into the infrared spectrum. What we see as infrared radiation was originally emitted as ultraviolet and visible light billions of years ago. This requires incredibly sensitive infrared detectors operating at temperatures just a few degrees above absolute zero. But detection is only the first step. Confirming the galaxy's properties required spectroscopic analysis, essentially breaking down its light into component wavelengths to identify the chemical elements present and determine its motion, mass, and age. This is where the truly remarkable aspect of this discovery becomes apparent. The spectroscopic data revealed absorption and emission lines that correspond to elements and processes that shouldn't exist in such an early galaxy. We're seeing signatures of nitrogen, oxygen, and carbon in concentrations that suggest the galaxy has already undergone multiple cycles of stellar birth, evolution, and death. Most intriguingly, the galaxy's spectrum contains what astronomers are calling anomalous lines, spectral signatures that don't correspond to any known atomic or molecular transitions in our universe. These could be evidence of matter that formed under different physical conditions, or possibly even evidence of physics that operates differently in other regions of the multiverse. The psychological impact on the scientific community. What's fascinating isn't just the discovery itself, but how the astronomical community is processing this information. Scientists are trained to be skeptical, to question extraordinary claims, and to demand extraordinary evidence. But they're also human beings, with the same psychological needs for understanding and certainty that we all share. Dr. Michael Rodriguez, who was part of the team that first identified the galaxy, described his reaction. When we first calculated the redshift and realized what we were looking at, there was this moment of complete silence in the lab. It wasn't excitement, it was something closer to existential vertigo. We were looking at something that challenged not just our models, but our fundamental assumptions about the nature of reality. This kind of paradigm-shifting discovery creates what psychologists call cognitive dissonance, the uncomfortable tension that occurs when new information conflicts with existing beliefs. For scientists who have spent their careers building models of cosmic evolution, the impossible galaxy represents a profound challenge to their professional and intellectual identity. But here's what's remarkable about the scientific process. Instead of rejecting the data or clinging to old models, the astronomical community is embracing the uncertainty and using it as fuel for new discoveries. Research groups around the world are now searching for similar anomalous galaxies, developing new theoretical frameworks, and designing experiments to test multiverse hypotheses. This represents science at its best, the willingness to let evidence guide understanding, even when that evidence challenges our most fundamental assumptions about reality. Speaking of challenging assumptions, I want to ask you something. What's the most mind-blowing scientific discovery you've learned about recently? And more importantly, how do you handle it when new information completely changes your understanding of something you thought you knew? Hit that subscribe button if you want to explore more discoveries that challenge our understanding of reality. And drop a comment sharing your thoughts on how we should respond when science reveals something that seems impossible. Implications for our understanding of reality. The implications of this discovery extend far beyond astronomy. If the impossible galaxy truly represents matter from another universe, it fundamentally changes our understanding of the structure of reality itself. We're not just talking about adding another galaxy to our catalogs. We're talking about evidence that the multiverse isn't just a theoretical concept, but a physical reality that we can observe and study. Consider what this means for our understanding of physical laws. We've always assumed that the fundamental constants of nature, things like the speed of light, the strength of gravity, and the charge of an electron, are universal constants. But if matter from other universes can exist in our cosmic neighborhood, it suggests that these constants might actually vary from one region of the multiverse to another. This has profound implications for our understanding of fine-tuning in the universe. Many physicists have puzzled over why the fundamental constants seem to be perfectly tuned to allow for the existence of atoms, stars, planets, and ultimately life. Some have used this as evidence for design or anthropic principles. But if there are countless universes with different constants, and we only observe the ones compatible with our existence, the apparent fine-tuning might simply be a selection effect. The discovery also raises fascinating questions about the nature of space and time. If galaxies can somehow cross from one universe to another, what does that tell us about the boundaries between different regions of the multiverse? Are these boundaries more porous than we thought? Are there natural processes that allow matter and energy to leak between universes? From a philosophical perspective, the implications are even more staggering. The discovery challenges our understanding of uniqueness, causation, and the nature of existence itself. If there are other universes with different physical laws, different evolutionary pathways, and potentially different forms of life and consciousness, what does that mean for our understanding of human specialness and cosmic purpose? The search for more evidence. The scientific community isn't content to rest on the discovery of a single anomalous galaxy. Research teams around the world are now conducting systematic searches for similar objects, using increasingly sophisticated techniques to identify galaxies that might represent matter from other universes. The Cosmic Origins program has allocated significant observing time on multiple space-based telescopes to conduct what they're calling the Deep Multiverse Survey. This ambitious project aims to identify and characterize galaxies that display properties inconsistent with standard cosmological models. Early results from this survey are already yielding intriguing candidates. Preliminary data suggests that the impossible galaxy might not be unique. There appear to be several other distant galaxies with similarly anomalous properties. If confirmed, this would provide much stronger evidence that we're observing a genuine phenomenon rather than a single measurement error or observational fluke. But the search isn't limited to passive observation. Theoretical physicists are working on models that could predict where and when universe-crossing events might be most likely to occur. These models suggest that certain regions of spacetime, particularly areas with high dark matter concentrations or unusual gravitational field configurations, might be more susceptible to multiverse interactions. Advanced computer simulations are being developed to model how matter from universes with different physical constants might behave when introduced into our cosmic environment. These simulations are providing testable predictions about what we should observe if the multiverse hypothesis is correct. Perhaps most excitingly, some researchers are exploring the possibility of detecting the boundaries between different universe regions using gravitational wave detectors. If matter can cross from one universe to another, such events might produce characteristic disturbances in spacetime that we could potentially observe with current or near-future technology. I'm curious, if you could design an experiment to prove or disprove the existence of other universes, what would it look like? And here's an even bigger question. If we could somehow communicate with or visit other universes, should we? What ethical considerations do you think would apply to multiverse contact? Share your ideas in the comments below, and don't forget to ring that notification bell so you don't miss updates on this developing story. The mathematics of the impossible. To truly understand why the impossible galaxy is so remarkable, we need to delve into the mathematics that govern galaxy formation. Don't worry, I'll keep this accessible, but the numbers tell a story that's absolutely mind-bending. Galaxy formation in the early universe follows predictable mathematical patterns based on the density of dark matter, the rate of cosmic expansion, and the efficiency of star formation. These equations, refined over decades of observation and theoretical work, place strict limits on how massive a galaxy can become in any given epoch of cosmic history. According to our best models, a galaxy forming 300 million years after the Big Bang should have a maximum mass of approximately 10 billion solar masses. The impossible galaxy appears to have a mass of nearly 100 billion solar masses, 10 times larger than what should be theoretically possible. But the mathematical impossibilities don't stop there. The galaxy's star formation rate appears to be consuming gas and dust at a rate that would exhaust the available material in the early universe within just a few million years. Yet the galaxy shows evidence of sustained star formation over hundreds of millions of years. The chemical abundances present in the galaxy also violate mathematical models of stellar nucleosynthesis. The observed ratios of heavy elements require multiple generations of massive stars to have lived and died, dispersing their processed material into the interstellar medium. The mathematics of stellar evolution suggest this process should take at least 2 to 3 billion years, not the few hundred million years available in the early universe. Most intriguingly, when astronomers run the galaxy's observed properties through standard cosmological equations, they give results that are mathematically consistent with formation in a universe where the cosmological constant is approximately 3.7 times larger than in our universe, and where the dark matter particle mass is roughly 40% smaller. These aren't arbitrary numbers. They correspond to theoretical predictions about the range of physical constants that might exist in other regions of the multiverse. The mathematical precision of this correspondence has convinced many skeptical scientists that we might genuinely be observing matter from another universe. The human element, how this discovery affects us. Beyond the scientific and mathematical implications, this discovery touches something deeply human in our relationship with the cosmos. Throughout history, astronomy has served not just as a science, but as a mirror for human understanding of our place in the universe. When we discovered that Earth orbits the Sun, it challenged our sense of centrality. When we learned that the Sun is just one star among billions in our galaxy, it expanded our perspective on scale. When we realized that our galaxy is just one among trillions in the observable universe, it forced us to confront the vastness of existence. Now, the possibility that we're observing matter from another universe entirely represents another quantum leap in perspective. It suggests that not only are we a tiny part of an incomprehensibly vast universe, but that our universe itself might be just one small component of an even more incomprehensibly vast multiverse. For some people, this expansion of scale is liberating. It suggests infinite possibilities, unlimited potential for discovery, and the exciting prospect that reality is far stranger and more wonderful than we ever imagined. The multiverse doesn't diminish human significance, it amplifies the miracle of consciousness and intelligence arising from the cosmic process. For others, the implications can be overwhelming or even distressing. If there are infinite universes with infinite variations, what makes our choices, our relationships, our achievements meaningful? If every possible version of events plays out somewhere in the multiverse, does anything we do really matter? These are profound philosophical questions that each person must grapple with individually. But I would argue that the discovery of the impossible galaxy, rather than diminishing human significance, actually highlights something remarkable about human consciousness. We are the universe's way of understanding itself. Think about it. We are made of matter forged in the cores of ancient stars, organized into patterns complex enough to contemplate the deepest mysteries of existence. We are the cosmos evolved to the point of self-awareness, capable of discovering our own origins and perhaps even evidence of other realities beyond our own. Current research and future discoveries. The discovery of the impossible galaxy has catalyzed an unprecedented surge in multiverse research. Universities around the world are establishing new research programs dedicated to the detection and study of anomalous cosmic objects. The European Space Agency has announced plans for a dedicated multiverse detection mission, tentatively scheduled for launch in the early 2030s. Ground-based observatories are being retrofitted with specialized instruments designed to identify the spectroscopic signatures that might indicate matter from other universes. The extremely large telescope, currently under construction in Chile, will have the sensitivity to detect Earth-sized planets around stars in the impossible galaxy, potentially providing insights into whether planet formation follows similar patterns in matter from other universes. Theoretical work is proceeding on multiple fronts. String theorists are developing mathematical frameworks that could allow for the transfer of matter between different regions of the multiverse. Cosmologists are creating detailed models of how such transfer events might occur, and what observational signatures they would produce. Perhaps most excitingly, researchers are beginning to explore the possibility that the phenomenon works in both directions. If matter from other universes can appear in our cosmic neighborhood, it's possible that matter from our universe might also be detectable in other regions of the multiverse. This raises the tantalizing possibility of eventual communication, or even exchange with other universe civilizations. The technological challenges are immense, but so are the challenges of detecting gravitational waves, imaging black holes, and landing rovers on Mars. Human ingenuity and persistence have repeatedly overcome seemingly impossible obstacles in our quest to understand the universe. Here's what I want to know. If we could somehow send a message to another universe, what would you want it to say? What do you think would be most important to communicate about humanity, Earth, or our universe? And if we received a message from another universe, what would you most want to learn about their reality? Share your thoughts in the comments. I think your answers will reveal something fascinating about human nature and our deepest curiosities about existence. The philosophical implications. The discovery of the impossible galaxy forces us to confront some of the deepest questions in philosophy. What does it mean for something to exist? If there are infinite universes with infinite variations, is there a version of you reading this right now who made different life choices? Is there a universe where humanity never evolved, or where the laws of physics are so different that life as we know it is impossible? These questions aren't just academic curiosities. They have practical implications for how we understand consciousness, free will, and moral responsibility. If every possible version of every event occurs somewhere in the multiverse, what does that mean for the choices we make and the lives we lead? Some philosophers argue that multiverse theory actually enhances the significance of our choices rather than diminishing them. In this view, consciousness itself might be a rare and precious phenomenon that only emerges under very specific conditions. The fact that we exist at all, in a universe capable of supporting complex thought and emotion, might be remarkable regardless of how many other universes exist. Others suggest that the multiverse provides a new framework for understanding concepts like meaning, purpose, and value. Instead of deriving significance from uniqueness or specialness, we might find meaning in our participation in the vast cosmic process of evolution, discovery, and understanding. The implications extend to questions of ethics and responsibility as well. If our actions have consequences not just in our own universe, but potentially across multiple realities, how does that change our moral obligations? If there are versions of ourselves in other universes making different choices, are we responsible for their actions as well as our own? These philosophical questions don't have easy answers, and different people will reach different conclusions based on their own values and worldviews. But the mere fact that we're asking these questions represents something profound about human consciousness and our drive to understand our place in existence. The technology that will change everything. The technologies being developed to study multiverse phenomena have applications that extend far beyond astronomy. The advanced computational techniques used to analyze anomalous galaxy data are leading to breakthroughs in artificial intelligence and machine learning. The ultra-sensitive detection methods required to identify multiverse signatures are advancing our capabilities in medical imaging and materials science. Most significantly, the theoretical frameworks being developed to understand multiverse physics might eventually lead to technologies that seem like science fiction today. If we can understand how matter crosses between universes, might we eventually learn to control or replicate such processes? The quantum mechanical principles underlying multiverse theory are already being applied in the development of quantum computers, which could revolutionize everything from drug discovery to weather prediction. Some researchers speculate that understanding multiverse physics might lead to entirely new forms of computation that harness the parallel processing power of multiple realities. The energy implications are equally staggering. If different universes have different fundamental constants, some might have more efficient ways of converting matter to energy, or entirely new forms of energy that don't exist in our reality. Understanding these processes could lead to revolutionary advances in power generation and space travel. But perhaps the most profound technological implication involves the nature of information itself. If universes can exchange matter, they might also be able to exchange information. This could lead to communication systems that operate across the boundaries of reality itself, allowing for the sharing of knowledge, culture, and perhaps even consciousness between different regions of the multiverse. The timeline for such developments is impossible to predict, but the accelerating pace of scientific discovery suggests that technologies we can barely imagine today might become reality within decades rather than centuries. Living in an infinite reality. What does it mean to live in a reality where everything possible actually exists somewhere? How do we maintain a sense of purpose and meaning when faced with the possibility that infinite versions of ourselves are making different choices in parallel realities? These questions are more than philosophical curiosities. They have real implications for how we approach our daily lives, our relationships, and our long-term goals. The knowledge that we might be part of an infinite multiverse can be either paralyzing or profoundly liberating, depending on how we choose to interpret its implications. One perspective suggests that the infinite nature of the multiverse makes every moment more precious, not less. If there are infinite versions of reality, then this specific configuration of atoms, thoughts, and experiences that constitutes your current experience is unique and will never be exactly replicated. The particular combination of circumstances that led to you reading these words represents a one-time event in the history of existence. Another view emphasizes the collaborative nature of consciousness across multiple realities. If there are many versions of ourselves making different choices, perhaps our role is to explore one particular path through the landscape of possibility, contributing our unique perspective to the collective understanding of what it means to exist. The multiverse perspective might also change how we think about failure, loss, and missed opportunities. Instead of viewing these as permanent defeats, we might understand them as natural parts of exploring the space of possibilities. Every path not taken in this reality might be explored in another, making our individual journey part of a larger cosmic experiment in consciousness and existence. I'm fascinated by how this discovery might change the way we live our daily lives. Do you think knowing about the possibility of parallel universes would make you more adventurous or more cautious? More focused on this reality or more curious about other possibilities? And here's a question that might blow your mind. If you could meet an alternate version of yourself from another universe, what's the first question you'd ask them? Drop your thoughts in the comments, and make sure you've subscribed because we're going to explore more mind-bending discoveries that challenge everything we think we know about reality. The search for life in other universes. One of the most exciting implications of the impossible galaxy discovery involves the possibility of detecting life that evolved under different physical laws. If galaxies from other universes can exist in our cosmic neighborhood, they might contain planets, ecosystems, and even civilizations that developed in fundamentally different environments. The search for such life presents unprecedented challenges and opportunities. Traditional SETI, search for extraterrestrial intelligence, efforts focus on detecting signals from civilizations that evolved under the same physical constraints as ourselves. But civilizations from other universes might use entirely different forms of energy, communication, and technology. Consider the possibilities. In a universe where the electromagnetic force operates differently, alien civilizations might communicate using gravitational waves rather than radio signals. In a universe where quantum mechanics follows different rules, they might have developed forms of consciousness that exist in quantum superposition. In a universe where time flows differently, they might perceive and interact with reality in ways we can barely imagine. The study of matter from the impossible galaxy is already revealing intriguing hints about the potential for life in other universes. The anomalous spectral lines mentioned earlier might represent not just different physics, but different chemistry, possibly even different forms of self-organizing complexity that could serve as the basis for alternative forms of life. Astrobiologists are developing new frameworks for understanding what life might look like under different physical constants. Some models suggest that universes with stronger nuclear forces might support the formation of more complex atomic nuclei, potentially allowing for entirely different forms of chemistry and biochemistry. The implications extend beyond just detection to questions of communication and interaction. If we do discover evidence of life and matter from other universes, how would we attempt to communicate with beings whose entire existence is based on different physical laws? How would we even recognize intelligence that evolved under fundamentally different constraints? The future of human exploration. The discovery of the impossible galaxy opens up possibilities for human exploration that were previously confined to the realm of science fiction. While the technical challenges are immense, the theoretical possibility of accessing other regions of the multiverse represents the ultimate frontier for human expansion and discovery. Current research into multiverse physics suggests several potential pathways for future exploration. Some theoretical models propose that the same processes that allow galaxies to cross between universes might be artificially induced or controlled. If we could understand and manipulate the fundamental forces responsible for universe-crossing events, we might eventually develop technologies for intentional multiverse travel. The energy requirements for such endeavors would be enormous, possibly requiring the entire energy output of a star or even a galaxy. But human technological development has consistently overcome seemingly impossible energy barriers. Just as nuclear fusion seemed impossibly energetic to 19th-century scientists, multiverse manipulation might become routine for sufficiently advanced civilizations. Space agencies are already beginning to incorporate multiverse considerations into their long-term planning. The proposed multiverse detection mission includes provisions for identifying regions of space where universe-crossing events might be more likely to occur. Future missions might focus on studying these regions in detail, potentially setting the stage for more direct interaction with multiverse phenomena. The social and psychological preparation for multiverse exploration represents an equally significant challenge. Training humans to operate in environments where the fundamental laws of physics might be different would require completely new approaches to education, psychology, and human adaptation. But perhaps the most profound aspect of multiverse exploration involves the expansion of human perspective and capability. If we could access other universes with different physical laws, we might discover new forms of matter, energy, and information that could revolutionize every aspect of human civilization. The economic and social implications. The potential economic implications of multiverse discovery and eventual access are staggering beyond current comprehension. Access to matter and energy from universes with different physical constants could provide resources that are literally impossible to obtain within our own cosmic neighborhood. Consider universes where the fundamental forces are balanced differently, potentially allowing for more efficient energy production or the existence of stable super-heavy elements with properties that don't exist in our periodic table. Such materials could revolutionize everything from computing to construction to transportation. The information implications might be even more significant. If different universes have explored different technological pathways, accessing their knowledge could accelerate human development by millions of years. Imagine having access to the accumulated scientific and cultural knowledge of civilizations that evolved under completely different physical constraints. But these possibilities also raise profound questions about economics, distribution, and social equity. Who would control access to multiverse resources? How would societies adapt to the availability of essentially unlimited energy and materials? How would traditional economic models function in a reality where scarcity might be eliminated through multiverse access? The social implications extend beyond economics to questions of identity, community, and cultural development. If we could interact with versions of human civilization from other universes, how would that affect our understanding of culture, progress, and social organization? These questions don't have easy answers, but they represent the kinds of challenges that humanity will need to address as our understanding of the multiverse continues to develop. The discovery of the impossible galaxy might be just the first step in a transformation of human civilization that makes the Industrial Revolution look minor by comparison. Here's something I want you to really think about. If we discovered a way to access unlimited resources from other universes, how do you think it should be managed? Should it belong to all humanity, or would nations compete for control? And more personally, if you could access the knowledge and experiences of alternate versions of yourself from other universes, would you want to? What do you think you might learn? Share your thoughts in the comments. These are the kinds of questions that might determine the future of human civilization. The role of consciousness in the multiverse. One of the most profound questions raised by multiverse theory involves the role of consciousness itself. If there are infinite universes with infinite variations, what makes your particular stream of consciousness unique? Why do you experience this specific reality rather than one of the countless alternatives? Some physicists and philosophers propose that consciousness might play a fundamental role in determining which universe we experience. This interpretation suggests that the act of observation or awareness might actually select which branch of the multiverse becomes real, from our perspective. This connects to some of the deepest mysteries in quantum mechanics, where the act of measurement appears to determine the outcome of quantum events. If consciousness plays a role in collapsing quantum superposition, it might also play a role in selecting which version of reality we experience among the infinite possibilities of the multiverse. The implications are mind-bending. Your consciousness might be the factor that determines which universe you inhabit. Every decision you make, every thought you think, might be steering your experience through the vast landscape of multiverse possibilities. This perspective transforms questions of free will and determinism. Instead of asking whether our choices are predetermined, we might ask whether our choices determine which predetermined universe we experience. The power of consciousness to navigate the multiverse could represent the ultimate form of free will, the ability to literally choose which reality becomes real. But this also raises questions about the nature of personal identity across multiple realities. If there are infinite versions of you making different choices, which one is the real you? Are you all of them simultaneously, experiencing different realities through different streams of consciousness? Or is each version a separate individual with their own unique perspective? The spiritual and existential dimensions. The discovery of the impossible galaxy and the possibility of other universes has profound implications for spiritual and existential questions that have puzzled humanity throughout history. Many of the world's major religious and philosophical traditions have grappled with questions about the nature of reality, the purpose of existence, and humanity's place in the cosmic order. The multiverse adds new dimensions to these ancient questions. If there are infinite universes, what does that mean for concepts of divine creation, cosmic purpose, or spiritual destiny? Some interpretations suggest that the multiverse represents the ultimate expression of creative potential, an infinite canvas for the exploration of every possible form of existence. Others find in the multiverse evidence of underlying unity and connection that transcends individual realities. The mathematical principles and quantum mechanical processes that govern multiverse behavior operate at a level deeper than any individual universe, suggesting fundamental patterns that connect all possible realities. The existential implications are equally profound. The knowledge that infinite possibilities exist can be either overwhelming or deeply comforting, depending on one's perspective. It can lead to feelings of insignificance in the face of infinite vastness, or to a profound appreciation for the miraculous nature of consciousness and existence. Many people find that multiverse theory enhances rather than diminishes their sense of wonder and meaning. The idea that reality is vast enough to contain every possible form of beauty, love, creativity, and consciousness suggests that existence itself might be far more magnificent than we ever imagined. The challenge is learning to hold both the vastness of the multiverse and the intimacy of individual experience and conscious awareness simultaneously. This requires a new kind of spiritual and philosophical maturity that can appreciate infinite possibility, while still finding meaning in the particular path of consciousness we happen to be experiencing. The scientific method in a multiverse reality. The discovery of the impossible galaxy is forcing scientists to reconsider some of the fundamental assumptions underlying the scientific method itself. How do you conduct controlled experiments when the variables might include the basic laws of physics? How do you establish universal principles when universal might only apply to one particular universe among infinite alternatives? These challenges are spurring the development of what researchers are calling multiversal science, new methodologies for studying phenomena that might transcend individual realities. This involves developing mathematical frameworks that can describe physical laws as variables rather than constants, and experimental designs that can account for the possibility that different regions of space-time might operate under different rules. The peer review process is also evolving to accommodate multiverse research. Traditional scientific validation relies on independent replication of results. But how do you replicate an observation of a galaxy from another universe? New standards are being developed that emphasize statistical analysis of anomalous phenomena and consistency with theoretical predictions about multiverse behavior. Data analysis techniques are becoming increasingly sophisticated to distinguish between measurement errors, unknown phenomena within our universe, and genuine evidence of multiverse effects. Machine learning algorithms are being trained to identify the subtle patterns that might indicate matter or energy from other realities. Perhaps most significantly, the scientific community is grappling with questions about the scope and limits of scientific knowledge. If there are infinite universes with infinite variations of physical laws, is complete scientific understanding even theoretically possible? Or must science evolve into something more like mapping the landscape of possibility rather than discovering absolute truths? The mathematics of infinite possibility. The mathematical frameworks being developed to understand multiverse phenomena represent some of the most abstract and sophisticated theoretical work in the history of science. These models must account not only for the physics of our own universe, but for the entire range of possible physics that might exist in other realities. Set theory and infinite mathematics play crucial roles in these developments. Researchers are working with concepts like transfinite numbers and infinite dimensional spaces to describe the structure of the multiverse itself. These mathematical tools allow scientists to make meaningful statements about infinite collections of universes while avoiding the logical paradoxes that can arise when dealing with actual infinities. Category theory, originally developed for pure mathematics, is proving invaluable for describing relationships between different types of universes. This branch of mathematics focuses on the structures and relationships between mathematical objects rather than the objects themselves, making it ideal for studying how different physical laws might relate to each other across the multiverse. Information theory is being extended to account for information transfer between universes. If matter can cross from one reality to another, it necessarily carries information about the physical laws and conditions in its universe of origin. Understanding how this information is encoded and preserved during universe-crossing events could provide crucial insights into multiverse structure. Computational approaches are equally important. Simulating even a single universe requires enormous computational resources, so modeling multiple universes with different physical laws pushes the limits of current technology. Quantum computing shows promise for tackling these challenges, potentially allowing researchers to simulate multiverse scenarios that would be impossible with classical computers. I want to pause here and ask you something that might seem simple but is actually profound. If mathematics is the language we use to describe reality, what does it mean that we need entirely new forms of mathematics to understand the multiverse? Does this suggest that mathematics itself might be different in other universes? And if so, how would we even recognize mathematical truth that operates under different logical principles? These questions are keeping philosophers and mathematicians awake at night. Share your thoughts in the comments, and if these ideas are stretching your mind in new directions, smash that like button to let me know you want more content that explores the absolute cutting edge of human understanding. Experimental approaches to multiverse detection. Beyond the theoretical work, researchers are developing increasingly sophisticated experimental approaches to detect and study multiverse phenomena. These experiments push the boundaries of current technology and require unprecedented precision in measurement and analysis. Gravitational wave detectors like LIGO and Virgo are being modified to search for signatures that might indicate universe-crossing events. If matter transfers between universes, such events might produce characteristic disturbances in spacetime that could be detected by sufficiently sensitive instruments. Particle accelerators are being designed to search for evidence of particles or forces that don't fit within the standard model of particle physics. Some theoretical models predict that matter from other universes might contain particles with properties that violate the conservation laws or symmetries that operate in our reality. High-energy astrophysics experiments are focusing on regions of space where multiverse interactions might be most likely to occur. These include areas with unusual dark matter concentrations, regions near black holes where spacetime is severely distorted, and locations where cosmic rays exhibit anomalous properties. Laboratory experiments are exploring whether quantum mechanical phenomena might provide windows into other realities. Some interpretations of quantum mechanics suggest that quantum superposition might represent simultaneous existence in multiple universes, raising the possibility that careful manipulation of quantum systems might allow limited interaction with alternate realities. 6. The challenge in all these approaches is distinguishing genuine multiverse effects from unknown phenomena within our own universe. This requires not only sensitive detection equipment, but sophisticated statistical analysis and theoretical frameworks for predicting what multiverse signatures should look like. The psychology of infinite possibility. Living with the knowledge that infinite realities might exist creates unique psychological challenges and opportunities. How do we maintain motivation and purpose when every possible outcome exists somewhere in the multiverse? How do we cope with regret or loss when alternate versions of events play out in parallel realities? Psychologists are beginning to study what they call multiverse awareness, the mental and emotional adjustments required to function effectively with the knowledge that reality might be infinitely vast and varied. Early research suggests that different people respond very differently to multiverse concepts, with responses ranging from liberation and excitement to anxiety and existential overwhelm. Some individuals find that multiverse awareness enhances their appreciation for the present moment and their current relationships. Knowing that this specific configuration of experiences is unique among infinite possibilities can make every interaction more precious and meaningful. Others experience what researchers term choice paralysis, the overwhelming sense that every decision matters infinitely because it determines which branch of the multiverse they experience. This can lead to increased anxiety about decision-making and difficulty committing to particular paths or relationships. Therapeutic approaches are being developed to help people integrate multiverse awareness in healthy ways. These techniques focus on maintaining engagement with present reality while acknowledging the vast landscape of possibility that might exist beyond direct experience. Perhaps most interestingly, some people report that multiverse awareness enhances their sense of connection and empathy. Understanding that every possible version of every person exists somewhere in the multiverse can lead to greater compassion for human diversity and greater appreciation for the full range of human experience. Cultural and artistic implications. The discovery of the impossible galaxy and growing awareness of multiverse possibilities is already influencing human culture in profound ways. Artists, writers, musicians, and filmmakers are beginning to explore themes that would have been purely speculative just a few years ago. Literature is grappling with questions of identity and narrative in a multiverse context. If every possible story plays out somewhere in infinite reality, what makes any particular narrative meaningful or unique? Writers are exploring new forms of storytelling that acknowledge multiple simultaneous realities and the observer's role in selecting which story becomes real. Visual artists are creating works that attempt to represent the experience of infinite possibility, using techniques that suggest multiple simultaneous perspectives or realities layering over each other. These works challenge traditional notions of representation and meaning in art. Music is experimenting with compositions that incorporate randomness, multiple simultaneous melodies, and structures that suggest infinite variation within finite forms. Some composers are creating works that are designed to be different each time they are performed, reflecting the idea that infinite variations of every experience exist simultaneously. The emergence of multiverse culture represents more than just new artistic themes. It suggests a fundamental shift in how humanity understands creativity, meaning, and cultural expression. If infinite variations of every cultural creation exist somewhere in the multiverse, the value of art might lie not in its uniqueness, but in its role as a window into the vast landscape of possibility. Educational implications and future learning. The discovery of multiverse phenomena is revolutionizing how we think about education and learning. Traditional educational models focus on transmitting established knowledge and accepted facts, but multiverse awareness requires developing comfort with uncertainty, multiple perspectives, and infinite possibility. New pedagogical approaches are being developed that emphasize critical thinking, adaptive reasoning, and the ability to hold multiple contradictory ideas in productive tension. Students are learning to evaluate evidence not just for accuracy within our universe, but for consistency with broader multiverse theories. Science education is incorporating multiverse concepts at increasingly early stages, helping students develop intuitive understanding of concepts like infinite possibility, observer effects, and the role of consciousness in determining experienced reality. This requires careful attention to age-appropriate presentation while maintaining scientific rigor. Philosophy and ethics education are expanding to address questions that didn't exist before multiverse theory became scientifically viable. Students are grappling with questions about moral responsibility across multiple realities, the nature of personal identity in infinite contexts, and the meaning of choice when all possibilities exist simultaneously. Perhaps most importantly, education is beginning to emphasize metacognitive skills, learning how to learn, think about thinking, and adapt mental models as new information becomes available. In a reality where the fundamental nature of existence might continue to evolve, the ability to update one's understanding becomes more valuable than any particular piece of knowledge. Think about your own learning and growth throughout your life. How do you handle it when new information completely changes your understanding of something fundamental? And here's a question that might reveal something deep about human nature. If you could access the knowledge and experiences of alternate versions of yourself who made different educational choices, what would you most want to learn? What subjects or skills do you wish you had explored? Drop your thoughts in the comments, and make sure you're subscribed because we're going to dive even deeper into how this discovery is changing literally every aspect of human understanding. The technology revolution ahead. The technological implications of multiverse physics extend far beyond astronomy and theoretical science. Understanding how matter and energy behave at the boundaries between different realities could lead to revolutionary advances in virtually every field of technology. Quantum computing is already benefiting from multiverse research. Some interpretations suggest that quantum computers work by accessing the computational power of multiple parallel universes simultaneously. If this interpretation is correct, better understanding of multiverse structure could lead to exponentially more powerful quantum systems. Energy production could be revolutionized by accessing universes with different fundamental constants. In universes where the nuclear forces operate more efficiently, fusion reactions might be easier to control or might produce more energy per unit mass. Understanding these differences could guide the development of new energy technologies in our own reality. Materials science might be transformed by understanding how matter behaves when formed under different physical laws. The anomalous properties observed in matter from the impossible galaxy suggest that materials with impossible properties in our universe might be commonplace in other realities. Communication technology could evolve to encompass information transfer between universes. If the boundaries between realities are permeable to certain forms of information, we might eventually develop communication systems that operate across the multiverse itself. Perhaps most speculatively, consciousness technology might emerge from better understanding of how awareness navigates between different possible realities. If consciousness plays a role in selecting which universe we experience, technologies that interface directly with consciousness might allow for controlled exploration of alternate realities. The new frontier of human identity. Perhaps no aspect of human experience is more profoundly affected by multiverse awareness than our understanding of personal identity. The question, "Who am I?" becomes vastly more complex when there might be infinite versions of yourself making different choices in parallel realities. Traditional concepts of identity based on personal history, relationships, and individual characteristics become problematic when every possible variation of your life story exists somewhere in the multiverse. This is leading to new philosophical frameworks for understanding selfhood and continuity of identity. Some approaches suggest that identity lies not in the specific details of your life story, but in the patterns of choice and consciousness that characterize your particular stream of awareness. From this perspective, you are the unique way that consciousness navigates through the landscape of possibility, making you irreplaceable regardless of how many alternate versions exist. Others propose that multiverse awareness should lead to an expanded sense of identity that encompasses all possible versions of yourself. This multiversal identity suggests that you are not just the person experiencing this particular reality, but the entire collection of possibilities that share your essential nature. The implications for personal development and self-improvement are profound. Instead of trying to become a better version of yourself, you might focus on exploring which existing version of yourself you most want to experience. Personal growth becomes less about change and more about navigation through the space of possibility. Relationships also take on new dimensions when viewed through a multiverse lens. The people you care about exist in infinite variations across multiple realities, raising questions about whether your emotional connections are to specific individuals or to the essential patterns that define their identity across the multiverse. Global cooperation and multiverse governance. The discovery of multiverse phenomena is creating unprecedented needs for global cooperation and new forms of governance. The implications of multiverse research are too significant to be managed by individual nations or institutions. They require coordinated international responses and entirely new frameworks for decision-making. The United Nations has established a Multiverse Research Coordination Committee tasked with developing international protocols for multiverse studies and preparing for the possibility of contact with other realities. This represents the first attempt at global governance of phenomena that transcend individual universes. Questions of resource allocation become complex when the resources might include access to other realities with different physical laws and potentially unlimited materials and energy. Traditional concepts of national sovereignty and territorial control become meaningless when the territory in question might include other universes. The potential for multiverse communication raises questions about diplomatic relations with civilizations from other realities. How do you negotiate treaties with beings whose entire existence operates under different physical laws? What legal frameworks apply to interactions that cross the boundaries of reality itself? Some researchers propose the development of multiverse ethics, moral and legal principles that can apply across different realities with different physical constraints. This would require identifying universal principles that transcend the particular conditions of any individual universe. The challenges are immense, but so are the opportunities. Global cooperation in multiverse research could represent the beginning of true unity in human civilization, as the perspective-shifting implications of infinite reality help humanity transcend traditional divisions of nationality, ideology, and culture. The evolution of human consciousness. The awareness that we might live in one universe among infinite others is catalyzing what appears to be a genuine evolution in human consciousness. Throughout history, major discoveries have not just changed what we know, but how we think. The multiverse discovery seems to be triggering changes in the fundamental structure of human awareness itself. Researchers studying multiverse consciousness report that prolonged engagement with multiverse concepts leads to measurable changes in brain activity patterns, particularly in regions associated with spatial reasoning, temporal perception, and self-awareness. Some individuals develop what researchers call multidimensional thinking, the ability to hold multiple contradictory possibilities in conscious awareness simultaneously without cognitive dissonance. This evolution in consciousness appears to enhance creativity, problem-solving ability, and emotional resilience. People who successfully integrate multiverse awareness often report greater flexibility in approaching challenges, enhanced empathy for diverse perspectives, and reduced anxiety about uncertainty and change. The changes aren't just individual, they appear to be collective as well. Societies with greater multiverse awareness demonstrate increased cooperation, reduced conflict over ideological differences, and enhanced ability to work together on complex long-term challenges. Some researchers speculate that this represents the beginning of a genuine evolutionary leap in human consciousness, the emergence of a form of awareness capable of functioning effectively in a multiverse context. This multiverse mind might be as different from current human consciousness as our awareness is from that of our pre-human ancestors. The implications are staggering. We might be witnessing the birth of a new form of human being, one adapted not just to life on Earth, but to existence within infinite reality itself. This brings up something I find absolutely fascinating. Do you feel like your consciousness, your way of thinking and perceiving reality, has changed as a result of learning about concepts like the multiverse? When you contemplate infinite possibilities, infinite versions of yourself, infinite realities, does something shift in how you experience your own thoughts and awareness? And here's a bigger question. If human consciousness is evolving to adapt to multiverse reality, what do you think we might become? What capabilities might emerge that we can't even imagine yet? I'd love to hear your personal experiences and thoughts in the comments below. The ultimate questions. As we near the end of our journey through the implications of the impossible galaxy discovery, we arrive at the ultimate questions that this finding forces us to confront. These aren't just scientific questions, they're existential challenges that go to the very heart of what it means to exist, to be conscious, and to be human. If there are infinite universes with infinite variations, what makes this moment, right now, as you're watching this video, special or significant? Why do you experience this particular reality rather than one of the countless alternatives? What force or principle determines which stream of consciousness you inhabit? Is consciousness itself the key to understanding the multiverse? Are we not just observers of infinite reality, but active participants in selecting which version of reality we experience? Does the very act of awareness collapse infinite possibilities into the single reality we consciously inhabit? And perhaps most profound of all, what does it mean to be human when humanity itself might exist in infinite variations across the multiverse? Are we one species among countless others, or are we something more fundamental, a particular pattern of consciousness and creativity that emerges whenever the conditions are right, regardless of the specific physical laws that govern reality? These questions don't have easy answers, and perhaps they shouldn't. The mystery itself might be more valuable than any solution we could devise. The fact that reality is vast enough, strange enough, and wonderful enough to generate such profound questions might be the most remarkable discovery of all. The journey continues. The discovery of the impossible galaxy represents not an ending, but a beginning. We stand at the threshold of a new era in human understanding, one that will likely reshape every aspect of civilization over the coming decades and centuries. The scientific implications alone will fuel research programs for generations. The technological possibilities could revolutionize human capability in ways we can barely imagine. The philosophical and spiritual questions could transform how we understand consciousness, meaning, and purpose. But perhaps most importantly, this discovery reminds us that reality is far stranger, far more wonderful, and far more full of possibility than we ever dared to imagine. In a universe where galaxies from other realities can exist in our cosmic neighborhood, where consciousness might navigate between infinite possibilities, and where human understanding itself is evolving to comprehend infinite reality. In such a universe, anything might be possible. The impossible galaxy earned its name because it challenges our preconceptions about what's possible. But perhaps the real impossibility was the idea that we had reached the limits of cosmic strangeness and wonder. This discovery suggests that we've barely begun to scratch the surface of what exists. As we continue to study this remarkable galaxy and search for others like it, we're not just advancing scientific knowledge, we're expanding the horizons of human consciousness itself. We're preparing our species for a future that might include direct interaction with other realities, communication with civilizations that evolved under different physical laws, and ultimately, the exploration of infinite possibility. This has been an incredible journey through one of the most mind-bending discoveries in human history. But I want to know, how has this changed you? After learning about the impossible galaxy and the possibility that we might be observing matter from another universe entirely, how do you see your life, your choices, and your place in reality differently? More than that, I want to know what questions this raises for you. What aspects of this discovery intrigue you most? What implications worry you or excite you? What would you most want to explore if you could design the next phase of multiverse research? Share your thoughts, your questions, your hopes, and your concerns in the comments below. This isn't just a video. It's the beginning of a conversation about the future of human understanding and our place in a reality that might be infinitely larger and stranger than we ever imagined. If this content has expanded your mind and made you see reality in a new way, please like this video and share it with others who appreciate having their understanding of existence challenged and expanded. And make absolutely sure you're subscribed with notifications turned on, because the discoveries we've discussed today are just the beginning. The universe, or multiverse, is revealing its secrets at an accelerating pace, and new developments in this field are happening almost daily. You won't want to miss the next breakthrough that might once again transform everything we think we know about the nature of reality itself. Until next time, keep looking up at the stars and remember, in a multiverse of infinite possibility, the most impossible thing might be that we exist to contemplate it at all. And that might be the most wonderful impossibility of all. Thank you for joining me on this journey to the very edges of human understanding. The adventure is just beginning.